Swear to God, Gabrielle, what are you doing?
What are you talking about?
What do you mean you don't know what we're talking about? We have a central tendencies test tomorrow. Oh!
Are there any tutors on the internet?
Yeah, get on your computer and Google the Corn Academy.
Let's say I've got a set of numbers. 2.
Welcome to Gab Academy. Today we will be learning about measure of central tendency. The measure of central tendency is a value that represents a typical or central entry of a dataset. The three most commonly used measures of central tendency are the mean, the mode, and the median. The mean is the sum of the data entries divided by the number of entries. Mean equals average. Say we have a problem containing the numbers 18, 13, 14, 13, 16, 14, 21, 13, and 13. We're going to add all of these numbers together to get 135. Now we're going to divide 135 divided by 9. Because there are 9 numbers, and it's going to equal 15, so the mean is 15. There are two types of mean, population mean and sample mean. Population mean is nothing but the average of the entire group. The lowercase Greek letter U in the formula represents the population mean. The uppercase N represents the number of entries in a population. The sample mean implies that the mean of the sample is derived from the whole population randomly. The X represents the sample mean, and the lowercase n represents the number of entries in a sample. Mode is a data entry that occurs with the greatest frequency. We're going to use the same numbers that we use in the mean and put them in order. As you can see, 13 occurs the greatest amount of times, so the mode is 13. Since we are already talking about mode, bimodal is when two entries occur with the same greatest frequency. So say we have 3 1s, 2 4s, 4 6s, 1 7, 4 8s, an 11, and a 14. Since there are 4 6s and 4 8s, they have the greatest frequency, so the mode is 6 and 8. The median is the value that lies in the middle of the data when the data set is ordered. So we're going to use the same numbers that we used in the mean, and we are going to order them. So the easiest way that I find the median is to start crossing from the left to the right to see what's in the middle. The median is the middle value, 14. The range is when you subtract the highest number from the lowest number in a data set. So 21 minus 13 equals 8. So I'm going to begin drawing a graph, and on the x-axis, I'm going to start with 20, 40, 60, 80, and 100. And on the y-axis, I'm going to start with 20,000, 40,000, 60,000, 80,000, and 100,000. Then I'm going to draw a positive curve with some dots. This is just a rough graph to show you what an outlier is. An outlier is a data entry that is far removed from the other entries in a data set. This little dot over here is an outlier and can mess up a data entry. A weighted mean is the mean of a data set whose entries have varying weights. A weighted mean is given by this formula, where W is the weight of each entry X. I am going to draw a table based on weighted mean. On the left-hand column, there will be test scores, and the middle column will be the weight of each test score. We are going to multiply X times W, since it is in the formula, and put it on the right-hand column. I'm going to also write the formula on the right so you can see it better. So we're going to take the X times W column, the right column, and add all the numbers together and the middle column and divide them. So it's 88.6 divided by 1, which equals 88.6 is the weighted mean. The mean of a frequency distribution for a sample is the formula x equals x times f over n, where x and f are the midpoints and frequencies of a class. So we are going to draw another data table, and on the left-hand column we are going to have x, and in the middle column we will have the frequency, and then we will have on the right-hand column x times f. We are going to do basically the same thing in the last problem, just a little different. After putting all the numbers in the x and f columns, we are going to multiply them together on the right-hand column. Then we are going to add the frequency, all the frequency numbers together, which equals 50. Then we are going to add all of the xf numbers together, which equals 2089. Then we are going to write out the formula again just so we can see it, and we are going to divide 2089 divided by 50, which equals 41.8, which is the mean of frequency distribution. Now we will be talking about the shapes of distributions. A graph can reveal several characteristics of a frequency distribution. A frequency distribution is symmetric when a vertical line can be drawn through the middle of a graph of the distribution and the resulting halves are approximately mirror images. I will be drawing a blue curve and a vertical red line so you could see the mirror halves. A frequency distribution is uniform or rectangular when all entries or classes in the distribution have equal or approximately equal frequencies. A uniform distribution is also symmetric. A frequency distribution is skewed if the tail of the graph elongates more to one side than to the other. A distribution is skewed left, negatively skewed, if its tail extends to the left. This also shows the mean, mode, and median. A distribution is skewed right, positively skewed, if its tail extends to the right, which also can show the mode, median, and mean. I hope you guys learned a little something, and now here's for bloopers.
Google's the